7.4 Factored form of a quadratic function. Our goal for this section is to relate the factors of a quadratic function to the characteristics of its graph. Let's do an example. Graphing a quadratic function given in standard form. Sketch the graph of the quadratic function 2x squared plus 14x plus 12. State the domain and range of the function. Alright, so what do we know? The coefficient, spelled with two F's, the coefficient of 2x squared is positive 2, right? Because it's positive 2, I know the parabola opens up. So the parabola opens up. I'm going to factor this expression to see if I can find my x-intercepts, or my roots. So I have f of x is equal to 2x squared plus 14x plus 12. I can factor out a common 2. So I'm going to start with that. 2 times x squared plus 7x plus 6. So now I'm going to ask myself, what multiplies to 6 and adds to 7? Well, that's pretty easy. How about 6 and 1? X squared plus 1x plus 6x plus 6. Then I can group going to group that, and I'm going to group that. Next, I'm going to pull out my common factors. I can take out a common factor of x, so that this turns into x plus 1, and I can take out a common factor of 6, so that this turns into x plus 1. Next, I can write my factors. 2 times x plus 6 times x plus 1. This is my factored form. From this, it's really easy to tell what my x-intercepts are. My x-intercepts are going to be where my roots set equal to 0. So 0 is equal to x plus 6, x is equal to negative 6. 0 is equal to x plus 1, x is equal to negative 1. So my x-intercepts are x equals negative 6 and x equals negative 1. My y-intercept can be found by setting the value of y to 0. So f of 0 is equal to 2 times 0 plus 1 times 0 plus 6. That is equal to 12. So my y-intercept is 12. The axis of symmetry can be found quite easily now. I know my x-intercepts, and I know that my axis of symmetry is halfway between them, so I can take the average. Axis of symmetry. Negative 6 plus negative 1 divided by 2. X is equal to negative 3.5. This is the equation of my axis of symmetry. X is equal to negative 3.5. I can then find my vertex pretty easily by subbing in 3.5 for x in my original formula. So my vertex, f of negative 3.5 is equal to 2 times negative 3.5 plus 1 times negative 3.5 plus 6. Plug that into my calculator, and I get that f of negative 3.5 is equal to negative 12.5. Therefore, the coordinates for my vertex are negative 3.5, comma, negative 12.5. can then sketch my parabola using this given information. So I have my vertex of negative 3.5, negative 12.5. I have my x-intercepts of negative 6, 0, negative 1, 0, and I have my y-intercept of 0, 12. If I connect all of those dots together that I plotted, I'm going to get my parabola. The domain, of course, is going to be for all real numbers for x, and the range, because my parabola opens up, it has a minimum at negative 12.5. So y is greater than or equal to negative 12.5. Y is a member of the real numbers. Next question. We can also use a partial factoring strategy to sketch the graph of a quadratic function. For example, sketch the graph of the following quadratic function. F of x is equal to negative x squared plus 6x plus 10. State the domain and range of the function. Okay, if you look at this, it's kind of hard to think of two integers that multiply to negative 10 and add to 6. It's pretty much impossible. So what we're going to do instead is we're going to do a partial factor. So I have f of x is equal to negative x squared plus 6x plus 10. I'm going to factor a negative x out of these two terms. Negative x times x minus 6 plus 10. This is still equivalent. I can do this. Next, I'm going to determine 2 points in the function. I'm going to set each partial factor to 0. So negative x is equal to 0. So x is equal to 0. F of 0 will be equal to 10. X minus 6 is equal to 0. So x is going to be equal to 6. So f of 6 is also equal to 10. So the points 0, 10 and 6, 10 belong to this function. Because 0, 10 and 6, 10 have the same y-coordinate, they're the same horizontal distance from our axis of symmetry. So we can determine the equation by calculating the average of the x-coordinates of these 2 points. So 0 plus 6 divided by 2, x is equal to 3. This is the axis of symmetry. Next, I can determine the y-coordinate of the vertex. So this is my x-coordinate of my vertex, because it's equal to the axis of symmetry. Now I can actually determine the y-coordinate by plugging this value back into my equation. So I have f of 3 is equal to negative 3 squared plus 6 times 3 plus 10. If I plug that into my calculator, I get f of 3 is equal to 19. So my vertex coordinates are then 3, 19. Now using all of this information, I can graph this function. So I have my vertex at 3, 19. I can plot that point. I know that where y is 10, x is equal to 0, and x is equal to 6, so I can plot those points, and then I can sketch my parabola from those points. There's my fantastic parabola. The domain, of course, for x is all the real numbers. For y, here we have a maximum. The maximum y value is 19. So then I know that y is going to have to be less than or equal to 19 in order to be part of this function, where y is in the real numbers. Next question. We can determine the equation of a quadratic function given its graph. Determine the function that defines this parabola. Write the function in standard form. Well, right away, I can see my x-intercepts. So my x-intercepts are negative 1 and 4. In factored form, we have our zeros already given to us. So I'm going to write the formula for a factored form of a parabola. X minus r, x minus s. So y is equal to a, some constant, times our roots. Our roots are x minus r and x minus s. So we've located the x-intercepts, and now we're going to use them to determine the zeros of the function. So I can substitute in -1 and 4 for r and s. Y is equal to a times x minus -1, x minus 4. I'm going to get rid of some of these brackets and clean it up a little bit. X plus 1, x minus 4. Okay, now I just need to figure out, well, what's my value of a? Let's look back at this graph. My y-intercept is 12. So my y-intercept is 12. So that means the point coordinate for that is going to be 0, 12. That's the location of my y-intercept. I can substitute this 12 in for y so that I can find a. So I have my formula, y equals a times x plus 1 times x minus 4. So I'm going to substitute this 12 in. 12 is equal to, and I'm going to substitute this 0 in for x. A times 0 plus 1 times 0 minus 4. I can simplify to get 12 is equal to -4a. I can divide both sides by -4 to further simplify, and I get that -3 is equal to a. So then the vertex form of my parabola is going to be this. So I have y is equal to -3, that's my value for a, times x plus 1 times x minus 4. This is my vertex form. I can then write it in standard form by multiplying these out. So this is my vertex form. If I multiply these out, multiplying x times x, x times 4, 1 times x, 1 times 4, and then multiplying that by -3, I can get a standard form of my parabola. My standard form is then going to be -3 times x squared minus 3x minus 4. Sorry, this is y equals. So then my final form is going to be y equals -3x squared plus 9x plus 12. That is the standard form for this parabola. In summary, when a quadratic function is written as a factored form, y equals a times x minus r times x minus s, each factor can be used to determine a zero of the function by setting each factor to 0 and solving. The zeros of a quadratic function correspond to the x-intercepts of the parabola that is defined by the function. If a parabola has one or two x-intercepts, the equation of the parabola can be written in factored form using the x-intercepts and the coordinates of one other point on the parabola. The easiest other point is usually the y-intercept. Quadratic functions without any zeros cannot be written in factored form. You need to know, a quadratic function that is written in factored form has the following characteristics. The x-intercepts of the graph of the function are x equals r and x equals s. The linear equation of the axis of symmetry is x equals r plus s divided by 2. The y-intercept, c, is c is equal to a times r times s. If a quadratic function has only one x-intercept, the factored form can be written as follows. A equals x minus r squared. As you can see, we only have one root.